Hello everyone, good evening. Welcome back to Gate Wallah English YouTube channel. So I hope everyone is doing great. So tell me, till last class everything is fully clear or not? And before starting, everyone kindly comment that I am fully audible and visible to you all. Then I will start the lecture. Okay. So everyone kindly comment that if I am fully audible and visible to you all. Everyone kindly comment. Comment everyone that if I am fully audible and visible to you all, then I will start. So till last class we have discussed about. In the last class, sir, you have told me about unit hydrograph. Okay, we have discussed unit hydrograph. What is the volume of direct runoff hydrograph, that we have discussed. How to find volume of direct runoff when DRH is given to you. I will simply find the area under DRH. Okay, I will simply find the area under DRH, and you need to understand, sir, in this area under DRH I have three kinds of DRH. Basically one DRH is triangular, second one is trapezoidal, and the third one was simply, or you can say, smooth curve, in which we divided the ordinates. Have I told you this thing or not? Tell me. Yes or no? Okay, fully audible and visible to you all. Okay, so this is the concept. Then in the last class I told you how to convert unit hydrograph into DRH. Simply we have to multiply it by effective rainfall depth, and this is valid only because of linear response. Okay, so you told me about linear response, this is why, that's why we were able to multiply it. Okay, then we discussed how to use your DRH. How, if we are having different rainfalls, if we are having different rainfalls, then how we will use method of superposition. Okay, we will calculate for first rainfall, then we will calculate for second rainfall, and then at the end we will combine it. Okay, good evening dear, good evening. So this I have already told you, and I have given you some examples. Then at last I told you the most important formula, that FRH ordinate is unit hydrograph ordinate into effective rainfall depth plus base flow. This is the most important formula of your chapter, because many questions will be framed from this in your gate examination. I have also solved many questions yesterday. So in this, 6 parameters are given to you. 5 will be given in the question, and the last one will be asked from you all. Okay, so these are two types of questions which we have discussed. I told you this kind of question. Then again we solved one question in which FRH was given to me and unit hydrograph was asked. Then sir, we converted one kind of unit hydrograph into different kind of unit hydrograph. We converted the durations. Okay, so yesterday we discussed how to convert 3 hour unit hydrograph into 6 hour unit hydrograph, how to convert 3 hour unit hydrograph into 9 hour unit hydrograph into 12. In multiple terms we have discussed it. Okay, how to convert dr unit hydrograph into tr unit hydrograph, that we have discussed yesterday. But sir, we have discussed only the method of superposition. We have only discussed the method of superposition. Yes or no? We have only discussed the method of superposition, and today we are going to discuss the S curve also. Okay, we have only discussed the method of superposition only. Yes or no? I also gave you an example in which I converted 4 hour unit hydrograph into 12 hour unit hydrograph. Yes or no? Do you remember it? Wait a second. Wait a second, everyone. Yes. Okay, so this we have discussed yesterday. Now I gave you the example of 4 hour unit hydrograph, how we will convert it into 12 hour. Okay, we will lag it 3 times. I told you we will lag it 3 times. I will make this 4 hour rainfall convert into 12 hours. That's why I have to make it 3 times. That's why the DRH which I will obtain will be of 12 hour, and total rainfall will 3 centimeter. And at last I will divide the values by 3 to get the unit hydrograph of 12 hour. Okay, so these methods we have discussed yesterday. Now today we are going to discuss. Today we are going to discuss about. Now today we are going to discuss about S curve. Okay, what S curve is. We are going to discuss today what S curve is. How with the help of S curve we will convert it. Okay. Okay, sir, no problem. So we have to discuss basically S curve today. basically we have to discuss S curve today. Okay, sir. Now tell me what is S curve. See, first thing, with the help of S curve, you need to understand. First, we have to understand how to draw S curve, and basically you need to understand from with the help of S curve. Sir, see, what was the drawback in the method of superposition? Sir, the drawback in the method of superposition was that here we can only convert it into multiple times. Okay, if we have 2 hour unit hydrograph, we can convert it into 4 hours, 6 hours, 8 hours only multiple times. We cannot convert this 2 hour into 3 hour unit hydrograph. Okay, this was the drawback. Sir, we cannot convert 2 hour unit hydrograph into 1 hour. Okay, this was the drawback. We cannot convert it into 7 hour unit hydrograph. Why? Sir, multiple was when I will lag it. Sir, you told me that when I will lag it, I will only get the multiple duration. But if I want to convert this 2 hour duration into 3 hour, because rainfall can happen for 3 hour also. Rainfall can happen for 3 hour also, 7 hour also. So if I want to convert for non-multiple, if I want to convert my duration, okay, if I want to convert dr duration into tr, and which is not a multiple, then how I will do it? Then I will use S curve. Okay, then I will use S curve. So I will use it as a technique. I will write one thing here. I will write one point here, that it is a technique. Listen very carefully. See, it is a technique. It is a technique. It is a technique by which by which we can convert both possibilities are there. It is a technique by which we can convert a smaller duration hydrograph into longer duration, by which we can convert a smaller duration unit hydrograph into longer duration, a smaller duration unit hydrograph into longer duration. Okay, a smaller duration hydrograph into longer duration, and also I can convert longer duration into smaller duration. I can convert 2 hour into 1 hour. I can convert 3 hour into 1 hour. Okay, I can convert longer duration unit hydrograph. I can convert longer duration unit hydrograph into smaller duration unit hydrograph. Okay, longer duration unit hydrograph into smaller duration unit hydrograph. So both are possible. I can convert dr unit hydrograph into tr, where there it is not necessary, sir, where there it is not necessary that t is a multiple. Okay, sir, you can say that t equals md, but m can be any value, but m can take any value. M can take any value. It can be a fraction, it can be an integer. Okay, it can be any value. It need not be a multiple. There is no issues in that. Okay, but m can take any value. Okay, but m can take any value. So this is your S curve. Now this is the application part. Now what exactly S curve is? Okay, now what exactly S curve is? So S curve means I will see, we need to understand one thing, how we draw S curve first. So for a given unit hydrograph, let us say in question when you have to convert dr unit hydrograph into tr unit hydrograph, listen very carefully. If you have to convert this into this, then dr unit hydrograph will be given to me. Yes or no? It will be given to me. Yes, sir, it will be given to me. So if dr unit hydrograph is given to me, if it is given to me, then with the help of that dr unit hydrograph, I will first convert it into S curve. I will draw S curve. Okay, so I will write the very first point here, that S curve is drawn. S curve is drawn, or its ordinates are found out. Okay, with the help of dr unit hydrograph. S curve is drawn. S curve is drawn with the help of dr unit hydrograph. Okay, sir, no problem. Now what exactly S curve is? Sir, now tell me what exactly S curve is. Okay, what exactly S curve is? See, S curve is the resulting direct runoff hydrograph. I will explain this point with the help of an example also. First, let us write the definition, then I will explain it to you. Okay. So, sir, S curve is the resulting direct runoff hydrograph. S curve is the resulting, S curve is the resulting direct runoff hydrograph. S curve is the resulting direct runoff hydrograph when a continuous rainfall, when a continuous rainfall, when a continuous rainfall, when a continuous rainfall of, when a continuous rainfall of constant intensity, constant rainfall excess intensity, of constant rainfall excess, constant rainfall excess intensity, intensity will be 1 by d centimeter per hour occurs. Okay, sir. Okay, so if you want to understand this point, this is the major definition of your S curve. So if you want to understand this point, we have to take an example. Okay, we have to take an example with the help of which we will easily understand what S curve exactly is. Okay, sir. So to understand this point, we have to take a unit hydrograph. Okay, we have to take a unit hydrograph. Okay, sir. Let us take a 2 hour unit hydrograph. We can take any duration unit hydrograph. Okay, we can take any duration unit hydrograph. Okay, sir. No problem. No problem. We can take any duration unit hydrograph here. So I will take 2 hour unit hydrograph. Okay, sir. So let us say 2 hour unit hydrograph is given below. Okay, 2 hour unit hydrograph is given below. So let us take it as, so these are the values of time, these are the values of time here, and these are the values of discharges of 2 hour unit hydrograph. Okay, so let us take it as 0, 2, 4, 6, 8 like that. Okay, 0, 2, 4, 6, 8, 10 like this. Okay, till here only. We will not take it very big. Okay, only we have to understand what S curve exactly is. And let us take the value of discharges. So it will be 0. At 2 hour, obviously the discharge will peak up. Okay, it will, let us say it is 11, then let us say it is 25, then after 25 let us say it is 30, like this it is increasing, then it is 15, and then it is 0 like this. Okay, so these are the values which are given to you. Now you need to understand, see, this is a 2 hour unit hydrograph only. So sir, this is my 2 hour, this is a simple 2 hour unit hydrograph. Okay, no problem, sir. Now what I have to do, sir, if I will look at this unit hydrograph very closely, sir, rainfall has happened only for 2 hours. Okay, rainfall has happened only for 2 hours. Okay, you are saying, no dear, Kailash sir will teaching. Okay, Kailash sir will be teaching you hydrology. Okay, now. Okay, sir. So this is time, this is unit hydrograph. Okay, now sir, what else? Sir, we need to understand one thing, that here rainfall has happened only for 2 hours. If I will draw a graph here, okay, look at this graph. Okay, sir, tell me. See, in this graph, if I will look in this graph, sir, I will see because of 2 hour rainfall, sir, I will see because of this 2 hour rainfall, listen very carefully, because of this 2 hour rainfall, I have a discharge effect which is varying from 0 to 10 hours. Time basis, base time is 10 hours. That means the effect will vary from 0 to 10. The effect will vary from 0 to 10. Rainfall duration is only of 2 hours. This is 2 hours, and the total rainfall, effective rainfall depth is 1 centimeter. Effective rainfall depth is 1 centimeter, and this is the effect. Okay. Okay, dear. You are saying, sir, why I am not taking? See, because I am taking mathematics these days. Okay, I am taking mathematics. That's why Kailash sir was free, so he will take it. Okay, he's a very brilliant teacher. Don't worry. He is also very brilliant in hydrology. He is expert, that's why he will take it. Okay, don't worry about it. Okay. And if you want to study from me, you can study from here only, or any of the playlists which are available on YouTube. Okay, so you can study from there. Okay, so this is the 2R unit hydrograph which is given to me. Now, sir, now you are saying S curve is the resulting direct runoff hydrograph when a continuous rainfall of constant rainfall excess intensity occurs. Sir, we have to make this rainfall continuous. See, I have to make this rainfall happen again. Now what I will do, sir, I will make this rainfall again. Okay, I have to make this rainfall again. So what I will do here is, sir, this rainfall has to be done again. Yes or no? So if this rainfall will be done again, sir, if this rainfall will be done again, then what will happen? Sir, again I have to draw a simple unit hydrograph. Yes or no? Sir, again a simple unit hydrograph will be drawn or not? Starting from 2. So again, if I will draw a unit hydrograph, see, I have to draw the unit hydrograph 2, which will be lagged. Sir, which will be lagged. And that will start from 2. Okay, so I will shift this. I will write 0 here. 11 I will write here. Shift again. Lag it by 2. 30, 15 and 0. Simple. Now, sir, we have to make continuous. Do it again, sir. Again, make 1 centimeter 15. Again, do it. Again, sir, you have to draw the. Again, sir, you have to. Okay, sir, again we have to do rainfall. So what you are saying basically, sir, what you are basically saying is that you have to make continuous rainfall. Okay, these rainfalls will be continuous. These rainfalls will be continuous. Okay, so 2R, 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 total 5 times you will reach 10R. Listen very carefully. Okay, again you have to do it. Again you have to, you will not stop. Okay, you will not stop. You will keep on repeating it. You will keep on repeating it. So this 2R rainfall is happening again and again. So if it will happen again, sir, again I have to draw. Sir, again I have to draw its effect. See, if 2R rainfall again is there, then again we will get an effect. Again we will get effect. If again 2R rainfall is there, again we will get effect. Again 2R rainfall is there, again we will get effect. Again, sir, I will get effect. Again I will get effect. Like this you will never stop. Like this you will never ever stop. So you will get another unit hydrograph which will be starting from 4 now. So I will start from 4. 0, 11, 25, 30, 15 and 0. Again, when you will do the rainfall, you will get another unit hydrograph which will start from 6. So 0, 11, 25, 30, 15 and 0. Again, when I will do the rainfall, again I will start the unit hydrograph starting from 8, 0, 11, 25, 30, 15, 0. Again, sir, rainfall will be done. I will start from 10. I will start from 10, 0, 11, 0, 11, 25, 30, 15 and 0. Again, when rainfall will be done, again I will lag it. So like this, sir, like this, I will keep on lagging. I will keep on lagging. I will keep on lagging. And finally, I will add up all the values. Okay, so this is the way in which I will lag it. Okay, this is the way in which I will lag it, because I am ensuring that rainfall is happening again and again. Okay, I am ensuring that rainfall is happening again and again, sir, again and again, again and again, again and again, like this. Okay, sir, rainfall is happening again and again, and it's, see, even now also we haven't stopped. Okay, it will go further. It will go further because we have to, sir, we have to make continuous rainfall of infinite duration. This is your continuous rainfall, sir. This is your continuous rainfall. So continuous rainfall of constant rainfall excess intensity 1 by d. Now what is the meaning of 1 by d? Listen very carefully. See, meaning of 1 by d is, see, in this question, if 2R rainfall is there, if in 2R the effective rainfall depth is 1 centimeter, it's a unit hydrograph, na? So unit hydrograph means that direct runoff depth or effective rainfall depth or excess rainfall is 1 centimeter. So intensity will be what? Intensity will be 1 centimeter upon dr. D means 2. D means 2. Duration is 2. So this intensity is half centimeter per hour. This intensity is 1 by 2 centimeter per hour. We will keep it constant. Okay, sir, in every 2 hour 1 centimeter rainfall is there. Sir, in every 2 hour 1 centimeter rainfall is there. Okay, in every 2 hour 1 centimeter rainfall, 1 centimeter rainfall. In every 2 hour 1 centimeter rainfall. In every 2 hour, sir, 1 centimeter rainfall, like this. Okay, like this. In every 2 hour we have 1 centimeter rainfall, like this. Okay, so in every 2 hour 1 centimeter. So this rainfall excess intensity is constant, and we have to make sure that rainfall is happening again and again. We have to make sure that rainfall is happening again and again. So if rainfall will happen again and again, I will get this different unit hydrographs. Okay, I will get this different unit hydrographs which will be lagged again and again by 2 hours, like this, and so on and so forth. We will, even then after this I will not stop. Okay, now what I have to do, I have to combine it. Now what I have to do, I have to combine it. So when I will combine it, now when I will combine it, see, I will get certain values. Okay, sir, I will get certain values. You have to combine it. Tell me how much, when you will sum it up, what values you will be getting. Okay, tell me when you will sum it up, what values you are getting. So we will do it one by one. We will do it one by one, don't worry. Okay, we will sum it up one by one. We will sum it up one by one. Like this. So we have to sum it up. Okay, again we have a 0. See, not only this, you need to understand 0, 15, 32. Again 11 is written, again 0 is written. So it is continuing. Okay, you need to understand it is continuing. Okay, sir. So sum it up simply. Sum it up. When you will sum it up, the combined graph which you will get will be your S curve. When you will sum it up, the combined graph which you will get will be your S curve. Okay, now I will simply plus it. Sir, which subject will you take apart from mathematics? But dear, in which batch? See, in some batches still I will be teaching hydrology, BMC, irrigation, CPM part, steel and mathematics. These 6 subjects are allowed to me. If I will be getting time in between, so I will take these 6 subjects only. Otherwise, whosoever teacher will be free, he will take it. Okay, we all are a team and we have shared the loads. So simultaneously we will be teaching. Okay, now so we will add it. What we are getting here, sir, is, sir, first I will get a 0. Then 11 plus 0 is 11. Then 25 plus 11 is 36, sir. Then 30, 25, 11, 0. See, add all these 4. See, you need to understand, this is 11, 0 and this is also 11, 0. This is 25, 11, 0. This is also 25, 11, 0. I am telling you this thing because every time I will not draw this thing. This is only one time. I will directly tell you how to write from 2 hour unit hydrograph, how to write S curve ordinates directly. I will tell you. That's why I am showing you this thing. Okay. So you need to understand, if you want to sum up these, see, sum these values or sum these values, both are same. Both are same. Okay. So if I only have the 2 hour unit hydrograph, from that also I can draw the S curve. Okay. So simply add them. 30 plus 25 is 55. 55 plus 11 is 66. Okay. Now add this 15. So it will be 66 plus 15 will be, when you will add them, 30 plus 25 plus 11 plus 0 plus 15 will be 81. Okay. Now 0, 15, now all will be added. Okay. So when you will add this will be equivalent to this only. At last, when you will add this will be equivalent to this only. Okay, this will be equivalent to this only. So you will get 81 again. Now every time, now you will see that this entire line will get repeated. Now you will see that this entire line will get repeated. Okay, entire line. So now when entire line will be summed up, now see here there will be more columns. Here there will be more columns. So every time When you will sum up the entire columns, you will get 81 every time. You will get 81 every time. So what I am saying is that after base time of my basic 2R unit hydrograph, after its base time, okay, after base time, sir, the discharge has become constant. Okay, the discharge has become constant. I will draw S curve. I will draw S curve with this ink. So 0 is the first ordinate. 0 at 0. At 2 we have a value of 11. At 2 we have a value of 11. So it will be same. Okay, at 2 we have a value of 11. It will be same. So this is 11. This is 0. Then at 4R we have a value of 36. Now the graph will shoot up. Okay, this is 36, sir. This is 36. Then we have 66. Then we have, sir, 66. And at last we have 81. Okay, 81, 81, 81, 81, 81. Every time now we have 81. So if I will join them, I have to go steep up like this. This is your S curve. This is your S curve, and these are the points. This is your 0. This is 11. This is 36. 66. This is 36. This is 66. This is 36. 11. 0. This ink is more contrasting. This is 81. 81. 81. So you are saying, sir, that after your base time, after the base time, my discharge has become constant. My discharge, and this constant discharge is known as saturation discharge. QSAT, saturation discharge, or equilibrium discharge. Equilibrium. We call it as equilibrium discharge. Okay. Two names are there. See, formulas for it are also given to you. See, formulas are also there for saturation and equilibrium discharge. I will write it here. See, if someone asks you to write the formula for saturation discharge or equilibrium discharge, saturation discharge or equilibrium discharge is given by of a S curve, for a S curve is, what's the formula, sir? Formula is, we will write QSAT, or sometimes Q equilibrium will be written. It will be 2.778 A by D. Okay, this is the formula. This is the main formula in which I will get the value of discharge in meter cube per second. This area thing is given to me in kilometer square, and this duration is given to me in R thing. See, I can remember this formula, or I can do one more thing. Let us have one question here. With the help of which we'll understand beautifully. See, they are saying find equilibrium discharge. They are saying find equilibrium discharge for S curve if it is resulting from 2R unit hydrograph, if it is resulting from 2R unit hydrograph on a catchment area of 150 kilometer square, like this. Okay, so if this thing is given to you, you can simply find out the value of equilibrium discharge. Okay, if this is given to you, you can find the value of equilibrium discharge. How? See, equilibrium discharge can also, you all know that equilibrium discharge is runoff volume upon time. Okay, runoff volume is how much? See, runoff volume upon time, duration of rainfall basically. You can use the basics. Discharge is volume upon duration. Now volume is what? Volume is our area into effective rainfall depth. Runoff volume is area into effective rainfall depth. So I can use this also. Now area is given to me in kilometer square. So I will write the value of area. Area is 150 into 10 power 6 meter square. See, you have converted this kilometer square into meter square. Simple. Simply you have converted it. Simply you have converted area 1 kilometer square is 10 power 6 meter square. Yes or no? Effective rainfall depth is how much? Sir, it is a unit hydrograph. Sir, because it is a unit hydrograph, so the effective rainfall depth will be 1 centimeter. 1 centimeter means 1 centimeter is how much? I will divide by 100. I will divide it by 100. Okay, I will divide it by 100. Now, okay, what else? Duration. Duration is in R, 2 hour duration. So convert this 2 hour duration into seconds. We have to multiply it by 3600. Okay. So tell me what value we are getting here. Tell me what value we are getting here. Everyone tell me. So if I will solve this, how much value we are getting here? Tell me if I will solve this, what value we will be getting? Tell me everyone. So this is coming out to be, this is coming out to be this is coming out to be 208.33. Okay, 15000. Yes, it is coming out to be 208.33. Too much of discharge. Okay, this will be coming out to be, this is coming out to be 208.33 meter cube per second. You will get the discharge in meter cube per second. Now, sir, we can convert the units. Now simply, sir, we can convert the units. But one thing we need to understand. See, this is the area. This is the duration in R. So how this 2.778 has happened? Okay, so you need to understand. See, these are only the conversion factors. If you will solve these conversion factors, if you will multiply this 10 power 6 and divide by 100 and divide by 3600, this value will be equal to 2.778. So if you can convert, you can convert it. If you don't want to convert, simply follow this formula. In this formula, area is in kilometer square and duration is in R. Okay, area is in kilometer square and duration is in R. So what you are saying is, sir, 10 power 6 divided by 3600 into 100 is 2.778. This is A, this is D. Remaining is 2.778. Okay, so I can convert also and I can remember also. It's up to you. If you will solve directly, if you will solve using the trick, if you can solve it, if you want to solve it using the trick, Q equivalent discharge, you will simply write 2.778, directly write the area in kilometer square 150 and put the duration in hours. Okay, so 75 multiplied, this will 75 multiplied with this will be equal to 208.33. Same, both will be same. Okay, this is how we calculate, this is how we calculate saturation discharge. See, saturation discharge is the discharge which becomes constant after first base time. Okay, see, this was your, see, this was your basic, see, this was your the very first unit graph. Okay, and its base time is 0 to 10. Its base time is 0 to 10, and from 0 to 10 you need to understand, after 0 to 10 this graph has become constant. So I will write one point here, I will write one more point here. Wait a second, I will write one more point here. Okay, yes, So I will write one more point here, sir, that in this only after base time, okay, no place is left here. I will write what I will write after base time, after base time, after base time of after base time of dr unit hydrograph, the discharge of S curve, the discharge of S curve becomes constant. The discharge of S curve becomes constant. Okay, the discharge of S curve becomes constant, 81 81 like this. So you can see this is a S shaped curve. This is a S shaped curve. A kind of S is there, a kind of S is there. That's why we call it S shaped curve. Okay, we call it S shaped because it is a smooth, it is a smooth S shaped curve which is resulting from a continuous effective rainfall intensity of 1 by d centimeter per hour. If continuous rainfall will be there, I will get this graph. I will get this graph. Okay, I will get this graph. This is very simple. Now sir, I want to understand, sir, this is the long procedure. Every time I will not be writing all these things. Okay, so what is the procedure if I want to convert this to our unit graph directly into S curve? Okay, if I want to convert, sir, sir, this is my basic 2R unit graph given to me. How I can convert it directly? See, the first unit graph is going from 0 to 10. The base time is 0 to 10. Second unit graph base time is 2 to 12. Okay, second is 2 to 12. Then the third unit graph is starting from 4 and it is ending on 14. Fourth unit graph is starting at 6 and it is going to 16. Fifth unit graph starting from 8 and it is going to 18. Okay, last 10th. See, fifth hydrograph starting from 10 and it is ending on 20. Like this, it will never stop. Like this, you will see we will get different unit hydrograph. We have lagged it, we will again lag it, we will again lag it, because sir, rainfall is continuing. And when we'll get the combined DRH, that combined DRH will be known as your S curve. So S curve will happen from this. Okay, I hope this is clear to you. Now, how to write directly? Okay sir, tell me how to write directly. So let us write these values again. So let us write this to our unit graph again. Okay, so the time values which are given to me, sir, are 0, 2, 4, 6, 8 and 10, and the ordinates which are given to 0, 11, 25, 30, 15, 0, 0, 11, 25, 30, 15 and 0. Okay, so this was your basic 2R unit hydrograph. And if you want to convert it directly into S curve, how I will do it? Sir, please tell me how I will directly convert it into S curve. Sir, tell me directly how I will write. So if you want to write directly, there is a technique. If you want to write S curve directly, there is a technique. See, you have to do simply summation. You have to simply do the summation. Listen very carefully. See, I will write this point first. Okay, S curve is what? S curve ordinates. S curve ordinates. See, it's very simple. You simply have to sum it up. S curve ordinates are obtained by summation of dr. Okay, we have a dr unit graph and their ordinates will be given to you. You have to add them. Okay, we have to simply do the sum of dr unit graph ordinates. Okay, what you have to do? See, sum up the values sum of the values from 1 to n, okay, and get the S curve ordinate, and gets the S curve ordinate. Okay, if you want to get first ordinate, sum up to first only. If you want to get second S curve ordinate, sum up to 2, 1 and 2, like this. Okay, like this. Wait a second, let me show you in the figure also. So this is the main formula. So sir, if I want my S1, sir, you are simply saying that if I want my first ordinate, I will simply use this U1. Okay, sir. Sir, if I want my second ordinate, then I will sum U1 and U2. Sir, if I want my third ordinate, I will add U1 plus U2 plus U3 and so on so forth. And so on so forth. If I want to write SI, okay, I have to sum it up from 1 to, like this. I will sum up to the ith term. Okay, like this. So this is the value. So the first S curve will be only write 0. Now second order will be sum both of them. Sum both of them. So 0 plus 11 is 11. Now if you want to write third one, add these. See, because these three, so you need to understand these three and these three are same. No matter. Okay, it doesn't matter, sir. Sir, these two and these two are same. It doesn't matter, sir. Both are same. Now when you want to write the third S curve ordinate S3, you will do U1 plus U2 plus U3. So 25 plus 11 is 36. Now add them, because now the fourth ordinate is this and this is same. So directly I will write. It will be now 36 plus 30 is 66. 60 plus 15 is 81. 81 plus 0 is 81, like this. Okay, keep on adding. Directly you have obtained the S curve. Directly. Okay, directly you have obtained the S curve. Directly you have obtained the S curve. Now, if you want to see this in diagram, okay, if you want to see this in diagram, what we need to do here is, okay, no problem. It is not getting magnified. No issues. See, this is U. See, this is U1. This is U2. If you want to get this value, you have to add this to this. Okay, if you want to get the next value, you have to add this, and add the first one to reach here. Okay, if you want to get the next one, you have to add this, you have to add the last one, then again the last one, and at last the previous one. Okay, so every time you are moving ahead, you have to add the previous ordinate. Every time you are moving ahead, you have to add the previous ordinate. Okay, so this is why it is going on increasing. That's why it is going on increasing. Okay, so it's a kind of cumulative curve. S curve is nothing but, we can say, cumulative dr unit Hadoop. Okay, so S curve is nothing but, I can say it is cumulative, sir, it is cumulative dr unit Hadoop. Okay, so now can you convert your dr unit Hadoop into S curve? Tell me. Now can you convert it? So now we have understood how to convert 2 hour unit cutoff or d hour unit cutoff into S curve. We have understood completely what S curve exactly is. Okay, we can convert it anytime. We can convert it anytime. Okay. Okay, sir, no problem. We can convert it. Now, its use is ultimately why we are studying S curve, because we have to convert dr unit duration unit cutoff into tr. So how will I do that? How will I do that? That I will now tell you. Yes. Now the question is, sir, how I will convert my dr unit cutoff into tr? So there are basically 4 steps. There are basically 4 steps you need to understand. Sir, if I want to convert my dr unit hydrograph into tr unit hydrograph, so for that we have a method. Okay, for that we have a methodology. See, the step 1 is, first thing you have to draw S curve corresponding to this dr unit hydrograph. Okay, okay sir. So the very first step is draw, or you can say simply find S curve. Okay, find S curve, find S curve, find S curve corresponding to the very first 4 steps are there. 4 steps are there, and in these 4 steps you will easily get the answer. Okay, so find S curve corresponding to dr unit hydrograph. This is the first step. Okay sir. See, simultaneously we'll solve a question also. So that it is more clear to us. See, yesterday we have taken a question in which we have converted 4R unit hydrograph into 12R unit hydrograph. Okay, we will solve this same question, but not by method of superposition, but I will solve this question with the help of S curve. Same question. Okay, so this is your 4R unit hydrograph. Okay, sir, this is my 4R unit hydrograph. I will draw it again. Okay, what are the ordinates? 0, 5, 19, 25, 12, 0. 5, 19, 25, 12. 5, 19, 25, 12. Okay, so I will write the values 5, 19, 25, 12. So these are your 4R unit of values. Okay, 4R unit of. We have 4 time gap, 0, 4, 8, 12, 16, 20, like that. Okay, so this is your time gap, and this is your 4R unit hydrograph. Okay, okay sir, no problem sir, no problem. So this is my 4R unit hydrograph. Step number 1, sir, you are saying the step number 1 is that I have to convert it into S curve. I have to convert it into S curve. The very first step is simply we have to convert it. The very first step is we have to convert it. No problem sir, I will convert it simply. Okay sir, we are converting 4R unit hydrograph into 12R unit hydrograph. Okay, this is D and this is T. This is D and this is T. Okay, so how I will convert into S curve? So I will write the S curve values here. So I will convert it into S curve. Simple. See how I have to find out S curve directly, sir. You told me simply sum of the values. Okay, simply sum of the values. 0, 0 and 5 is 5. Sum all these values. 5 and 19 is 24. Okay, 9 by 24. 24 plus 25 is 49. Now sum up to here. 49 plus 12 is, sir, 61, and 61 plus 0 is 0. Cumulative values. S curve is done. Okay, so step number 1 is done. I have completed my step number 1. This is my step number 1. See, I will draw this in a graph also. We will show this thing in a graph also. so that it is more clear to us. Okay, sir, no problem. Okay, sir. So this is my S curve from 0 to 20. This was your 4R unit hydrograph. So this was your basic 4R unit hydrograph. And what you have done, you have converted into S curve. And this is your S curve. Okay, see, it has become constant after base time. Okay, so this is my S curve, the S1. This is my S curve S1. I hope this is clear to you. You have converted this 4R duration into, this is what? This is my 4R duration. In 4 hours, sir, 1 centimeter effective rainfall depth is there. Okay, sir, this is 4R. This is 20 because 20 is my base time. Okay. Now we'll move on to step number 2. Yes, dear. Hydrology will be finished by tomorrow or day after tomorrow. Okay. Hydrology will be finished. Basically, today is the most, you can say, today is your last important lecture. From tomorrow, we will only study flood and flood routing. So that are not important. Okay. It will be completed. So don't worry. Yes. So this is my S1. Now, second step is, now, sir, what is the second step? Sir, second step is we have to lag this S curve. Okay. We have to lag this S curve, lag the S curve by TR duration. TR. Okay. If you are converting 4R into 2R, 12R, you have to lag it by TR to obtain S2. Okay, to obtain S2. So what I will do here is I will lag this S curve by 12 hours. What I will do here is, sir, I will lag this S curve by 12 hours because T is 12. Okay, so I have to draw this graph again. See, I have to draw this graph again, but starting from 12. 12 will be coming somewhere here. Okay. So my S curve is going from 0 to 20, and after that it's become constant. Now I will start it from 12. Similar graph. Okay, similar graph. Again, I will draw the similar graph. Like this, I will start. Okay, is it same or not? Yes, it will be like this. It will become constant. Okay. It will become constant again. See, this is going from 0 to 20. This will go from 12 to 32. This will go from 12, see, 0 to 20. And if it will start, if this will shift here, it will go to 32. Okay. So this is what, sir? This is my S2. This is my S2. Red line is S2. So if this is red line, I will write S2 with red ink only. I have to start from 12 now. See, I have to start from 12 now. Okay, I will start from 12 now. So see, write this 0 in front of 12. Write this 5 in front of 16. Write this 24 here. Then 49. Then 61. And then this 0. Okay. So from 12 to 32. This is your second column. Okay, 4 columns are there only. 4 columns. Okay, sir. Okay, sir. Now what we have to do? Now we have to subtract S1 by S2. Okay, we have to do what? Now, sir, we have to simply subtract them. See, if I will subtract them, what I will get exactly? Sir, if I will subtract them, I will get 12 hours. See, I will get, let me write here. When I will subtract it, listen very carefully. See, one thing you need to understand, if in 4R, I am having 1 centimeter effective rainfall depth, then tell me in 12 hours, how much effective rainfall depth will be there? Tell me, can you tell this? Sir, if I am getting 1 centimeter effective rainfall depth in 4 hours, then how much effective rainfall depth will I will get in 12 hours? How much I will get in 12 are obviously 3. Yes or no? See, you can get this value simply. You have to divide 12 by 4. This is T and this is D. T by D centimeter is your effective rainfall depth for TR graph. Okay. So third step is obtain ordinates of 12-hour graph. So this is TR. Obtain ordinates of TR DRH. Obtain ordinates of TR DRH whose effective rainfall depth is T by D centimeter. Whose effective rainfall depth is T by D centimeter. See, this is effective rainfall depth. How I will get that? Simply by doing S1 minus S2. Simply by doing S1 minus S2. Okay. So if you want to find 12-hour DRH of 3 centimeter, 12 by 4 is 3. So what you are saying, sir? This is when you will subtract it, you will get 12-hour DRH. You will get 12-hour DRH of 3 centimeter basically. Okay. When I will subtract them, I will get it. Okay. Because that will give you the, see, this is first line, this is second line. You will get the volume between them. If you will subtract it, you will get the volume of direct runoff for 12 hours. You will get the volume of direct runoff for 12 hours. Subtract them. 0 minus 0 is 0. 5 minus 0 is 5. 24 minus 0 is 24. 14 minus 0 is 49. 61 minus 5 is 56. Like this. Okay, sorry, this is wrong. This value we have written wrong. See, 61 plus 0 is 61. 61. S curve becomes constant. S curve becomes constant like this. Sorry, this is 61. S curve becomes constant. Now, 61 minus 24 will be? 61 minus 24 will be what? Tell me. 51, 41, and then 37. 61 minus 41 will be what? 12. 61 minus 61 will be 0. Then 0. 0, 0 you will get again now. Now onwards you will get 0, 0. So this is your 12. So in graph you will see it like this. It is extending from 0 to 32. In graph it will be seen like this. It is trending from 0 to 32. This is your, okay, from 0 to 32 this graph. This graph is basically what, sir? This graph is 12-hour DRH. This is 12-hour DRH of 3 centimeter. Now, if I want to convert this 12-hour DRH of 3 centimeter, if I want to convert this 12-hour DRH of 3 centimeter into 12-hour unit hydrograph, if I want to convert it into 12-hour unit hydrograph, what I have to do? I have to simply divide S1 minus S2. I have to simply divide S1 minus S2 divided by T by D. Divided by T by D. T by D means 3. Sir, in 12 hours 3 centimeter, in 4 hours 1 centimeter. So this is because of 3 centimeter. So if you want to get unit hydrograph, divided by 3. So this is 0. This is 5 by 3. This is 8. This is 49 by 3. This is 56 by 3. This is 37 by 3. This is 4. This is 0. So this is your 12-hour unit hydrograph which you want to obtain. This is your 12-hour unit hydrograph. So at last we have a step. The last step is obtain TR unit hydrograph ordinates. Obtain TR unit hydrograph ordinates. How? Simply divide S1 minus S2 by T by D. When you will do this, you will get the values. Okay, you will get the values. See, this answer which you have got from S curve, it is same to the answer which you have got from the method of superposition. Same answer, exactly the same. 5 by 3, 8, 49 by 3, 56 by 3, 37 by 3. You can see it. See this, it is exactly the same as that of which we have obtained by method of superposition. Tell me, So using S curve, I will obtain the same answer. Using S curve, I will obtain the same answer. Sir, I can shift it anywhere. Okay. See, there is no need. You can shift. You need to understand, sir. In this, I have to shift by TR. In the second step, I have to lag S curve by TR. So if you want to convert 4R into 12R, you have shifted by 12R. Now, if you want to convert 4R, if you want to convert 4R into 2R, if you want to convert into smaller duration, you will shift this S curve only by 2R. You will shift this S curve only by 2R. If you want to convert 4R into 1R, you will shift this S curve only by 1R. If you want to convert this 4R into 7R, you will shift this S curve by 7R. So shifting can take place anywhere. It's a graph. It's a graphical method. So shifting can be done anywhere. It is not necessary that you are doing it in multiple times. Okay, it is not necessary that you are doing it multiple times. Okay, is this thing clear? Tell me if S curve is fully clear to you all. So if I have to show this in the graph, sir, if I have to show this in the graph, one problem is here. This pink line should be coinciding with this one. Okay, one problem is here that this pink line see why it should be coinciding. There is a reason to it. You need to understand one thing. See all these S curve values. See these values and see these values, more or less similar. 0, 5. Okay, so till 0, 5 it should be same. Till 0, 5 it should be same. Then it is starting to gain momentum. Okay. This is 4R unit of. So I hope this is clear to you. Now, if I want to see, this is 12R. This is my 12R DRH. So if I want to get the unit of, I will divide by 3. So simply divide this by 3. Sir, simply divide this by 3. This is my 12-hour unit hydrograph. This is the final thing which I want to obtain. So I hope this is very, very clear to you. Yes or no? Is this thing clear to you? Okay, so let us solve one gate problem. In this, ordinates of 1R unit hydrograph at 1R intervals starting from t equal to 0 are 0. How much? Are 0, 2, 6, 4, 2 and 1 at a gap of 1 hour interval. See, this is a unit hydrograph which is given to you, and the time gap which they are telling you, and the time gap is 1 hour interval. So this is 0, 1, 2, 3, 4, 5 like this. Okay, and 0, 1 and 0 like this. Okay, so this is given to you. Okay, so this is your 1 hour. This is your 1 hour unit hydrograph. Okay, no problem, sir. No problem. This is my 1 hour unit hydrograph. Okay, now what I have to do? See, the question is saying find the ordinate of 3R unit hydrograph for the catchment at t equal to 3. See, in this question, the question is demanding that I have to convert my 1 hour unit holograph into 3 hour unit holograph. Okay, this is the demand of the question. But sir, if I want to convert 1 into 3, it is a multiple. It is a multiple, so we have both options. We can convert this 1 hour unit holograph into 3 hour by using method of superposition also, and I can also convert it using S curve. Now you tell me which method should I use in this one. Tell me, you tell me. Now you tell me, if I want to convert my 1 hour unit holograph into 3 hour, I can convert it using S curve also, I can convert it using method of superposition also. It's up to us. It's up to us. If you want to convert it by method of superposition, you have to lag it 2 times. You have to lag it 2 times, okay? And if you want to do it by S curve, first you have to draw S curve, then you have to lag S curve by 3 hours. Then you have to do S1 minus S2, and at last you have to divide it by 3 T by D. Tell me, by which method should I solve? Tell me, by which method should I solve? This is a question which has been asked in GATE examination. Yes, you are saying to solve it by S curve. Okay, so I will solve it by S curve. Listen. Now, if I want to draw S curve, so how I will draw S curve? Ordinates are given to you. Simply you have to sum it up. Okay, sum it up 0. 0 2 is 2. Sum up till here is 8. Okay, 2 6 8. 8 4 is 12. 12 2 is 14. 14 1 is 15. And 15 0 is 15. Like this you will get the value. S curve will be constant. Now you have to write the S curve. You have to lag this S curve by 3 hours. Sir, why 3 hour? Why I have to lag it by 3 hour? Because you have to convert 1 hour into 3 hour. This is D and this is T. Since you have to convert it into 3 hour, okay, you have to lag it by 3 hour. Okay, so I will lag it by 3 hours. Okay, so all these values I will start writing from 3 only. I will start writing all these values from 3. 0 2. Okay, like this you will lag it. Like this you will lag all the values. Okay, so 0 2 8, like this, then 12, then 14, 15 and 15, like this. Okay, now after this you have to do S1 minus S2. Now S1 minus S2 will be giving you 3R DRH, 3R DRH of 3 centimeter. Why 3 centimeter? Because sir, 1 hour unit holograph means that 1 centimeter effective rainfall depth is there in 1 hour. Sir, in 1 hour 1 centimeter effective rainfall depth is there. So in 3 hours, how much will be the effective rainfall depth? Obviously 3 by 1. T by D, 3 by 1. Okay, T by D is 3 by 1. So this is your 3 centimeter effective rainfall depth. Subtract it. So 0 minus 0 is 0. 2 minus 0 is 0. 8 minus 0 is 8. 2 minus 0 is 2. 8 minus 0 is 8. 12 minus 0 is 12. 14 minus 2 is 12. 15 minus 8 is how much? 7. 15 minus 2 is 12 is 3. 15 minus 14 is 1. Then 0. Then 0 and 0. Like this you will. Okay, so this is your DRH. This is your DRH. Now what? I have to convert it into unit holograph. So 3R DRH is there. Convert it into 3R unit holograph. So 3 centimeter values are given to you. If you want to find 1 centimeter values, what you will do? You will divide by 3. Divide all these values by 3. Divide all these values by 3. 12 by 3 is 4. 12 by 3 is 4. 7 by 3. 3 by 3 is 1. Like this you will get all the values. Like this you will get all the values. Okay, I hope this is very, very clear to you. 8, 4, 12, 12 to 14. Okay, all these values are given to me. Now they are saying, so this is your final 3R unit holograph. They are saying to you that find the ordinate of 3R unit holograph at t equal to 3R. So at t equal to 3R, so if I will see at t equal to 3R, I am getting the answer as 4. Okay, what is the value at t equal to 3? 3R unit or hydrograph is having a ordinate of 4 meter cube per second at t equal to 3. So my answer will be, sir, so my answer will be 4 meter cube per second. Simple, 2 marks. Simple 2 marks problem. Okay. Simple 2 marks problem. This is how you will solve questions in your GATE examination. Okay, this is how you will solve questions in your GATE examination. So I hope this thing is very, very clear to you. Okay, so now S curve is also done. So we have completed the S curve. Okay. I hope S curve is very, very clear to you now. I hope S curve is very, very clear to you. We can solve some more questions. Okay, we can solve some more questions. So S curve is clear to you or not? Tell me. Try to solve this question. Try to solve this question. What they are saying, it is again a problem from GATE. Okay, from GATE examination. This is again a problem. Okay, sir, no problem. Let's solve it. So this question is saying a 4R unit of a catchment is triangular in shape with a base of 80 Rs. Okay. Okay, sir. So we have a triangular DRH. No problem. Of base 80. This is 80 Rs. Okay. What else? The area of the catchment is 720. Okay. So area is also given to me. Base flow is given to me as how much? 30 meter cube per second. Okay, sir. Base flow is given to me as 30 meter cube per second, and phi index is 1 mm per hour. Phi index is 1 mm per hour. 1 mm means 0.1 centimeter. 1 mm means, see, 1 mm if you will convert into centimeter, you have to divide by 10. You have to divide by 10. Okay. A storm of 4 centimeter occurs uniformly in 4 hours. That means total precipitation is 4 centimeter and total duration of rainfall is 4 hours. So all these things, P, phi, T, base flow, area, everything is given to you. Okay, sir, no problem. See, first thing which you can do here is, first thing which you don't have, from this question, sir, we can directly understand that we have to find what, sir? We have to find peak discharge. This is the very first step. We have to find 4R unit of peak discharge. First do this, then solve. Okay, it is question. The question is saying find the peak discharge of 4R unit of. Okay, sir, no problem. And the second part is you have to find the peak of flood discharge due to storm. So first find this peak of 4R unit of. How you will find it? Find it. Tell me how much you are getting. Tell me how much value you are getting. First find the peak of 4R unit. Okay, now if I'm audible now, see, you have to find peak discharge only. You have to find peak discharge only. Okay, now am I audible? So for that I will use the formula of basic triangular unit. I will do half. See, find the area under DRH, that will be equal to catchment area into effective rainfall depth, half QP. Base time is 80. Convert this R into seconds. 7 into kilometer square. Kilometer square is 10 power 6 meter square. And unit hydrograph we have 1 centimeter effective rainfall depth. Okay, for unit hydrograph we have 1 centimeter effective rainfall depth. So that is 1 by 100. So QP is coming out to be, now tell me, QP is coming out to be how much? If you will solve it, if I will solve it, QP is coming out to be, yes, tell me, QP is coming out to be, solve it quickly. 720 into 10 power 6 divided by 100. Yes, it is coming out to be 50 meter cube per second. This is coming out as 50 meter cube per second. Okay. Yes, this is coming out as, this is coming out to be 50 meter cube per second. Okay, so first answer is done. First answer is done, 50 meter cube per second. B option is done. Now they are saying find the peak flood discharge due to the storm. So if you want to find flood runoff hydrograph peak, I will use the formula. Flood runoff hydrograph peak is unit hydrograph peak, which you have just now found out, 50, multiplied by effective rainfall depth, which is P minus 5T, plus the base flow. You will use this formula. Very important formula. I have already told you many times. From this questions you will get. Okay. Yes, this is the formula from which you will get the questions. So, okay, sir, I will write the values. So, unit hydrograph peak is 50 meter cube per second. P minus 5T, total precipitation is 4 centimeter. Check it. Total precipitation is 4 centimeter. Phi is 0.1. Total duration is 4 hour. Okay, so this is 4 centimeter, sir. This is 4 centimeter. Phi is 0.1 centimeter per hour multiplied by 4 hour. Multiplied by 4 hour. Okay. Add 30 meter cube per second. That is the base flow. So what I will get? 50 meter cube per second. So 4 minus 0.4 is 3.6. 3.6 centimeter. See, this is 50 meter cube per centimeter. This is 50 meter cube per second. 50 meter cube per second per centimeter. Why per centimeter? Because it is because of unit hydrograph. Okay. 50 meter cube per second discharge is there when we have 1 centimeter effective rainfall depth. So if we have 3.6 centimeter effective rainfall depth, we will multiply 50 by 3.6. We will multiply 50 by 3.6. And we'll add 30 meter cube per second. So 50 into 3.6 is 180. 180 plus 30 is 210. Like this, you will solve your gate questions. Okay. Like this, you will solve your gate problems. Okay. So FRH is 210. FRH is 210. Which option will match? A option will get corrected. Okay. One more thing. This is meter square per second, but this is a misprint. It is meter cube per second. Okay. Everywhere the discharge will be given to you in meter cube per second. Simple. So have you understood this problem? Okay. So this is very simple. Now we'll continue from here in the next class. Okay. I hope this is very, very clear to you. Yes, so this is your last problem. From here we'll continue in the next class. Okay. So tell me if any problem is there. This is also a question from gate examination. Let us solve. This is the last one. Then we'll end it. Okay. This is the last question for today. We'll solve it and then we'll end our class. Try to solve this. Let me see if you are able to solve it or not. Same kind of problem. Same kind of problem. Tell me the answer to this one. Yes. So have you solved it? See what we have to do in this one. They are saying find the peak of 3 hour unit runoff. Okay. Average rainfall for a 3 hour duration. That means time duration is 3 hour. Total storm duration is total rainfall is 2.7 centimeter. So total rainfall is 2.7 centimeter. Loss rate is how much? Loss rate is how much? 0.3 centimeter per hour. Loss rate is how much? 0.3 centimeter per hour. The flood runoff hydrograph has a base flow of, so base flow is how much? Base flow is 20 meter cube per second. So everything is given to you. Everything is given to you. P, phi, T, everything is, and produces a peak flow of 210. Now flood runoff hydrograph peak is given to you. Flood runoff hydrograph peak is given to you as 210 meter cube per second. So peak you have to find out. How will you find the peak of 3 hour unit hydrograph? Okay. Sir, I will use my basic formula. Okay, this is the basic formula. Now FRH peak you have is given to me. I have to find UH peak. Okay, I have to find UH peak. Multiply by P minus phi T plus base flow. FRH peak is how much? 210 meter cube per second. Unit of peak I have to find out. Total precipitation is how much? 2.7 centimeter. Phi value is how much? Phi value is 0.3 centimeter per hour. Every hour we are losing 0.3 centimeter water in infiltration, multiplied by duration of rainfall, which is 3 hour again, plus the base flow is 20 meter cube per second. So very first step is you have to subtract base flow from your flood runoff hydrograph. Okay, when you will subtract 210 from 20, when you will subtract 210 from 20, okay, you have to divide it by 2.7 minus 0.3 into 3 is 2.7 minus 0.3 into 3 is this is 0.9. So 2.7 minus 0.9 is 1.8. This is meter cube per second. This is centimeter. So the unit error of peak which I am getting is, tell me how much we are getting? 190 divided by 1.8. So 190 divided by 1.8 is 190 divided by 1.8 is how much? 105.55. Okay, 105.55 like this. Okay, so 105.55 meter cube per second per centimeter. Per centimeter means that for every 1 centimeter effective rainfall depth, this is the discharge which we will be getting. Okay, this is the discharge that we will be getting. Okay, so we have solved one question in which we have found out the unit runoff and one question in which we have found out the flood runoff hydrograph. These are very important questions. That's why I am making you solve this one. Okay, these are very important when it comes to your gate examination. Okay, because these kind of questions have been framed many a times in your gate examination. Okay, every time you will see these kind of questions have been framed in your examination. Okay, so basically in today's class what we have discussed, in today's class we have understood about S curve, what S curve is. If I will continue the dr duration, if I will continue the rainfall for infinite duration, then I will get the S curve. How to get it, we have understood properly. How to get the S curve ordinates directly, that also we have understood. What is equilibrium discharge, saturation discharge, that also we have covered. Okay, so all these things we have discussed properly, S curve and everything. Okay, so I hope this is very, very clear to you. And we have solved some problems today also. So these were the problems which we have solved. I hope these questions are very, very clear to you. Okay, so here we'll end our class, and tomorrow we'll catch up with the one little topic, instantaneous unit order, I will tell you in this one. And tomorrow we'll start flood. Okay, flood and flood routing. So basically tomorrow and day after tomorrow will be your last class of hydrology. Okay, so good night everyone, stay blessed, take care. We'll catch up tomorrow with flood and flood routing.